In this demonstration, we're going to be showing you the effects of reverberation in a room similar to a factory. We have a sound source here, we'll call it a boombox. We have a sound generator here, which is producing pink sound. We have a recording device here, which is going to record the reverberations in this room. The reverberations are recorded in hertz over the spectrum from 125 hertz up to 4,000 hertz. We're going to be seeing how many seconds the sound continues to reverberate. This is typical of a factory. Hard surfaces on the wall, hard surfaces on the floor. The only sound absorbing material is a perforated ceiling. The best way to demonstrate reverberation right now you can hear the sound bouncing around. And so what we do is often we introduce acoustic curtains so that it breaks up the sound in the room. The light can still get in, the curtains are running parallel with the light source. Consequently, we can not be affected adversely by sound coming from somebody working on a lathe, somebody working on welding, and somebody working in a machine on a grinder. Harsh sounds. We will still hear the sound, but it will not be reflected sound as well. Reflected sound is what we're seeking to eliminate. Reverberation is what we're seeking to eliminate. We've had the pink sound producing frequencies right across the spectrum. The sound level was fairly uniform across the whole frequency range. We were observing around 30 decibels. This allows us to get a good reverberation for every frequency. That's what we're looking for. When we're looking at a wall and we're wanting to work out the sound isolation between, let's say, home units, where we have noise in one unit and noise in another unit, we want about a 40 decibel drop, 50 decibels between the two units. The spectrum we're looking at is from 125 hertz up to 4,000. We want an average decibel drop of between 40 and 50 decibels. We don't want to listen to the person next door singing in the shower, creating disturbing sounds for us in the other unit. This is the complaint you often hear of strata title people, where the sound is coming through the concrete floor to the unit below or the unit adjacent. This is to give us, how can I say, some privacy and some enjoyment of our space, not the space of next door. This is why we have these recording devices. So while I was shaking the bell, the frequencies that were highlighted here were 2,000, 4,000, 8,000 and 16,000. All high frequencies. Normally when we do the testing for acoustics for rooms, we are purely looking from 125 hertz up to 4,000 hertz. People in home units, in normal residential places, aren't running around ringing bells, which is very high frequencies. The standard tests that we do for buildings is restricted to 125 up to 4,000. After 4,000, we assume that people aren't going to be introducing high frequencies. We're in another industrial area. It's confined space this time, but we still have the problem of sound. Hard surfaces, hard floor, hardly any reflective or sound-absorbing material on the ceiling. Unfortunately, in a lot of industrial areas, we are confined to the area that we can work in. These machines are roughly 1 metre apart. The layout is thought through, but we still have the problem of sound. Reverberation isn't the issue here, it is the actual level of sound. You'll note that our workers here have the appropriate equipment on, the appropriate PPE equipment. Work health safety is now the issue. Work health safety ensures that we are not exposed to 70 decibels continuously. If you were exposed to 70 decibels for 8 hours, you would have permanent hearing loss. The earmuffs and the protective equipment that they're wearing protects their eyes as well. This way, the sound level is considerably reduced within acceptable limits. Normally, with background noise, most councils are happy if we have a background noise level of about 30 decibels. That's when you've got traffic noise, perhaps some aircraft, trains, and the like. At the university here, we've got no extraneous noise. We've got no traffic noise, aircraft, no industry anywhere nearby. And so therefore the background noise level is about 20 decibels. This is conducive to an environment where study is sought to be understood and learnt.